Hello, welcome to another lesson in geometry. Today we're covering section 2.2, conditional statements. So conditional statements are if-then statements, can be written in this form, and we have a hypothesis here, and we have a conclusion here. And a conditional statement is true if for every hypothesis, the conclusion is also true, okay? All right, so underline the conclusion of each if-then statement here. So if the weather is nice, then we will go swimming. So this is the conclusion, we will go swimming, okay? If I ride my bike to softball practice, then I will get there on time. So the conclusion here is I will get there on time, okay? All right, vocabulary builder. First word in here is converse, it's our only word. Related words are convert and conversion. So the definition, the converse of something is its opposite. So we're going to do that today, find the converse of a conditional statement. And it's because the prefix con means together and verte means to turn, so we're going to together turn the two parts around, okay? All right, so finish writing the converse of each statement. If I study, then I pass the geometry test. So the converse is to turn the two parts around. So together and put them back together. So this would be if I pass the geometry test, then I study. Okay, so we're just changing the hypothesis and the conclusions places. All right, and we just had to write in the blue part, but we have both. So if I am happy, then I laugh. All right, so the blue part should go first. So if I laugh, then I am happy. Now notice we're not making any statements about whether these are true conditional statements. We're just rechanging them around to the converse, okay? So if I have a summer job, then I can buy a new bicycle. So the converse will be, if I can buy a new bicycle, then I have a summer job. Then I have a summer job. Okay, let's flip it over and go through what a conditional statement is. So our key concept, conditional statements, and then also the converse of conditional statements. So a conditional statement is an if-then statement, and it might not be written with the words if and then, but it can be translated into an if-then statement, which we will have to do later, okay? So the symbols here for it are P and then an arrow pointing to Q, where P is our hypothesis and Q is the conclusion. So if we want to think about the conditional statement, it would be the opposite, or the converse of this conditional statement would be the opposite. Q points to P, okay? All right, so a hypothesis is a part P following the if, and the conclusion is the part Q following the then, okay? So if P then Q can be rewritten as P implies Q. So P is a subset of Q. So if the P thing is true, then the Q thing is true, okay? So if P is equal to tears and Q is equal to sadness, what are two ways to read this statement? This will say, if tears, let's write that again. Then sadness. Or we could say, tears implies sadness. Okay. All right, identifying the hypothesis and the conclusion. See, this part can be hard sometimes. If the angle measures 130, then the angle is obtuse. Well, this one's nice because it's already written in if-then form. So an angle measures 130. That's our hypothesis. And then the angle is obtuse. This is our conclusion. So complete each statement in if-then form. The hypothesis is the part following the if. The conclusion is the part following the then. Circle the hypothesis, underline the conclusion. So this is my hypothesis, and this is my conclusion. Notice the conclusion and the hypothesis do not include the if and the then words. Okay? They're the things that come after those. All right. How can we rewrite dolphins are mammals as a conditional? So this is a little bit trickier. There's no if and then. The tip is off about who's the hypothesis and who's the conclusion. So circle the correct statement. So are all dolphins mammals or are all mammals dolphins? So we need to think of who's the subset. So in this case, we're doing like this. So here is the smaller set. This is dolphins. And in here is the big set. This is mammals. Okay, so dolphins belong to the mammals. So dolphins are a subset of mammals. Okay. All right, so let's try this. We're going to say all dolphins are mammals. That's the true one. This one's definitely not true because humans are mammals, but we're not dolphins. And dogs are mammals, but they're not dolphins. Okay. All right, so the set of dolphins is inside the set of mammals. All right. So the smaller set is the hypothesis, and the larger set is our conclusion. So we're going to use this to change it into an if-then form. So if an animal is a dolphin, then it is a mammal. And that's how we can change dolphins are mammals into an if-then statement. Okay, and you're going to be doing that in your classwork and on the quiz, so make sure we practice it a little bit. Okay. All right, on the third page, we have finding the truth value of a conditional. So is the conditional true or false? If it is false, then you have to find the counterexample. So what we want to think of for if-then statements or conditional statements. So if the hypothesis, then the conclusion is for everything that makes this true, does it also make that true? Okay. All right, so here's our example here. If a month has 28 days, then it is February. So we're saying, hey, if this month has 28 days in it, then that month's February. Okay. So cross out the months that have at least 28 days. Well, January has 31, so it has 28. February has 28, sometimes it even has 29. March has 28 because it has 31. April has 30, so that's at least 28. So all of these months have at least 28. So is this conditional statement going to be true or false? It's going to be a false statement. Okay. If a month has 28 days and it's February. Here's an counterexample about January. January has 31, so it has 28 days in it, and January is not February. Now, what they really probably meant to say to make this a true statement would be if a month has exactly 28 days, then it's February, or has, less than 29, okay, or less than 30. So they tried to write this conditional statement, not the book. They did it as an example to show why it's false, but the person who might have been writing this just didn't quite understand conditionals enough. They needed to be very exact in the hypothesis, okay? All right, down below, take a key concept here, related conditional statements. Statement, how to write it. A conditional statement, use the hypothesis and conclusion. So if P, then Q, okay? I like the symbol way better. P implies Q, that's the arrow. Converse. Converse we already talked about, it's to flip it around. So the Q and P switch places. So if Q, then P, or Q implies P, okay? And then we have two new ones, inverse and contrapositive. All right, so we're gonna have to learn all of these terms, conditional, converse, inverse, contrapositive, and be able to change between them. All right, so the inverse is to negate the hypothesis and conclusion. Don't change their position, but just change them to the opposites. So if not P, then not Q. Or, in this case, not Q implies P, so if not Q, then P. So that's our contrapositive. So inverse is to change them both to not. Contrapositive is to change their order and change them both to not. Okay? Now, some or all of these may be true. All right? So that we don't know. We have to look at them each one individually. All right, so a conditional statement. So use the statement below to write each conditional statement. So we have angle A measures 98, so angle A is obtuse. So if angle A measures 98, then angle A is obtuse. Okay, that's our conditional statement. Just uses the hypothesis and the conclusion. Okay. All right. The converse is to flip it around. If angle A is obtuse, then angle A measures 98. Okay. Now, I would say that this one here, we don't ask to tell the truth or value of this, but the first one would be true. Angle A is 98, then it's obtuse. If angle A is obtuse, then it measures 98. I'm going to say that one's false. Okay. Now we weren't asked to tell that, but just notice, just because you flip it around doesn't keep its value true or false. We have to look at it and say, hey, are all obtuse angles, are they 98? And then I can think of a counterexample. A 100-degree angle is not 98. Okay, it is obtuse, but it's not 98. All right, so our inverse is to not here. Okay, so if not angle A measures 98. So if angle A is not 98 degrees, if angle A is not 98 degrees, then angle A, I want that to be in blue, then angle A is not obtuse. So all I did was change to not. I negated each part. So I said not 98, not obtuse. That's what the inverse does. And let's think about the truth value of that for a second. Angle A is not 98 degrees. So that means it's any other angle other than 98, any other measure. Angle A is not obtuse. So I could say angle A was 100. That would make the hypothesis true. And the conclusion would then be false because 100 is definitely obtuse. Okay. All right. Contrapositive. Contrapositive, we want to not only negate them, but we also want to flip them around. So we took our old conclusion, which was it's obtuse, and we're going to change that to the opposite. So angle A is not obtuse. We're going to write that as our hypothesis. And then we're going to take our old hypothesis, make it the conclusion, but also make it not. So angle A is not 98 degrees. Okay. All right, so let's think about the truth value of this one just for fun. Angle A is not obtuse, so that means it's acute angle. Therefore, angle A is not 98 degrees. Oh, that's a true statement. Okay. All acute angles, no acute angle is going to be 98 degrees. All right. Okay. So that concludes all of our stuff here. Okay. And let's flip it over. But real fast, let's just look back and put in the implies part. So here we have P, the hypothesis implies Q. For converse, we flip it around and we say Q implies P. For inverse, we say not. So not is that little squiggly in front. So not P implies not Q. And for contrapositive, we not things, we negate the things, but we also flip around. So not Q implies not P. Okay? And we'll practice these with hand signals in class next time. All right, problem number 4, writing and finding truth values of statements. Our first part is to write the converse, the inverse, and the contrapositive of the conditional statement. And this is our conditional statement. If a vegetable is a carrot, then it contains beta carotene. So we can do the converse, inverse, and contrapositive without knowing anything about these facts. It's just where do we put the parts, hypothesis, and conclusion. So converse, we change the conditional statement so the hypothesis becomes the conclusion and the conclusion becomes a hypothesis. So we've already moved the conclusion to the hypothesis part. The vegetable contains beta carotene, and we need to flip it around, and then it is a carrot. So that vegetable needs to be a carrot then. Okay. The inverse doesn't change the position of the hypothesis and conclusion. It just negates both of them. So if the vegetable is not a carrot, then it does not have beta carotene in it. Okay? And then the contrapositive changes the conditional positions, hypothesis, and conclusion, and it also negates. So if the vegetable does not contain beta carotene, then it is not a carrot. Okay? So inverse and contrapositives always have the word nots in it, and conditionals and converses usually don't. If the conditional starts with a not, though, then we have to flip that around. Okay, we'll see that in our classwork next time. All right, so to answer the truth of these, we have to know a little bit about vegetables. So I had to do some Googling and figure out what is beta carotene and what kind of vegetables have beta carotene. Okay, so beta carotene is in carrots and dark leafy greens and squash, all those vibrant vegetables, sweet potatoes, things that look all orangey and red or dark green. It is not in vegetables like mushrooms, most mushrooms, or a regular potato. Okay, so just the vibrant colored vegetables, which is most vegetables, by the way. All right, so converse, is the converse true? Our converse says if the vegetable contains beta carotene, then it is a carrot. Okay, so to get this to be true or false, we have to think of, hey, I pick up a vegetable, any vegetable I want, and it's got beta carotene in it, then that vegetable I pick up, is it going to be a carrot? So I can think of something that makes this true. A potato, regular potato. Okay, ooh, no E on the end of that. And that regular contains beta carotene. Oh, wait, no, not regular potato. I want a sweet potato here. Sorry. Sweet potato contains beta carotene, so that's okay. I can pick that for my hypothesis. And then this conclusion is going to be false. It's a carrot. No, sweet potatoes aren't carrots, but they do have beta carotene in it. All right, now, if the vegetable is not a carrot, so once again, I can pick up a sweet potato. That makes the hypothesis true. Sweet potatoes are not carrots. Okay? All right. It does not have beta carotene. Oh, that's a false statement. My sweet potato does have beta carotene. It's not a carrot. Okay, it's a sweet potato, so it makes the hypothesis true. I picked up the vegetable that's not a carrot. I picked up a sweet potato, but it does have beta carotene, so the conclusion is false. So if you can think of something that makes this part true and this part's false, then the whole thing is false. Okay? All right, so the vegetable does not contain beta carotene. So can we think of a vegetable that does not contain beta carotene? Okay, well, sure, a regular potato. Then does it make this part false over here? Oh no, a regular potato is not a carrot. All right, so there are some other vegetables that don't have beta carotene. A mushroom. So I can pick a mushroom here. A mushroom does not contain beta carotene. Up, it's also not a carrot. So this is a true statement. Okay, and you'll find in most cases the conditional and the converse share the same truth value, and the inverse and contrapositive share the same truth value. And sometimes all four of them share the same truth value. Okay, and then sometimes there's one that's messed up. So usually it's like 2 and 2 or all four are the same. All right. All right, so your lesson check. Did you understand what we were talking about? So your classmate, and this is where you pause the video again, okay? Do this first and then come back and check, and it'll let you know whether you really understand, okay? So an error analysis, welcome back. Your classmate rewrote the statement, you jog every Sunday as, if you jog, then it's Sunday. What is your classmate's error, and then correct it? So circle the hypothesis and underline the conclusion of your classmate's conditional. So this was the classmate's hypothesis, and underline it. So this is the conclusion. Circle the counterexample for your classmate's conditional. Okay, so which one of these would make our hypothesis true and the conclusion be false? So you jog on Saturday. Okay, you jog on Saturday is you're jogging, and it's not Sunday. So this is our counterexample. Okay. You don't jog and it's not Sunday is not a counterexample. You don't jog doesn't make the hypothesis part true. That fails our hypothesis. You're not jogging. It's not Sunday. That doesn't matter. Okay. All right. So write the conditional statement that best represents you jog every Sunday. Okay. This should be this. If it is Sunday, then you jog. Okay? Because remember that Sunday is a subset of jog. We might jog on other days, but Sunday we always jog on. We could also jog on Tuesdays and Thursdays and Fridays, but Sunday is always a jog day. So Sunday is a subset of jog. The subset has to be the hypothesis, and the big set has to be the conclusion. Okay? All right, so check off the vocabulary words you understood, conditional, hypothesis, conclusion, and then decide about how well you really knew that converse, the contrapositive, and the inverse. Do you need to go back and make sure that you know which ones flip to where? Okay, so like if I said this, could you match contrapositive, conditional, inverse, and converse with the right one here? Okay. All right, I'll see you in class next time.